All right, what's up? This is the lesson video for Tuesday and Wednesday. Tuesday, we just literally finished the Explorer. I'm not going to make a whole video for that because I already made a video for that. So that's the last video. So if you want to go watch that, that is on Monday's video. For Tuesday, it's just we took time to finish it, go over any questions people had, and kind of just re-detail out the graphing, okay? Now, there is a Math Connections worksheet, so make sure to turn this in. This assignment, this is the Explorer number 2. It is due on Tuesday, so make sure to get that turned in. That also is the last assignment of the second trimester, so it's the last assignment, so make sure to get that turned in. Okay, we will be having journal check number 10, and we will be having that on Friday. Here's everything that you need right over there. All the stuff that you need right there. So make sure that you have all that stuff in your journal. So pause this video, look through your journal, make sure you have all the things. We will be doing a couple entry activities between now and then. So just realize that, and that's how we'll get to the rest of the entry activities. And I will just do the journal check in class on Friday. All right. Let's keep pushing. So you will have this Math Connections worksheet. It should look like this. It should be this blue worksheet if you're in class. If not, on the assignment, look right here. I do actually have links to the actual assignment inside of Canvas, but then also if you need the Spanish version, it is in there as well. So you have links to the assignment if you need that, or like I said, I will be giving the worksheets out in class. So you have either option to go there, okay? Cool. So obviously that moves us on to Wednesday, and on Wednesday we are going to spend the majority of the time taking care of the Math Connections, and I'm just going to mention this rough draft. So there's a rough draft of the roller coaster CER. That is the last page of this notebook. That means we are just about done with this notebook. 131 and 132. You just have to have the written rough draft done for that. Okay, I do want to talk about this for a moment. If we have an earthquake drill, okay, right? Or if we have an actual earthquake, right? This is what we're supposed to do. So hold on. So if we have an earthquake, you should get underneath the desk. That way that whatever is up there on the roof doesn't fall down on you. Also, you should hold on to your desk. So you should grab on. Why? Because if the floor is moving, your desk might move. So you got to try and move with it, because you don't want anything to fall down on top of you. This is probably the most structural sound thing that you can get under. Because you never know when the earthquake's going to be, so you got to be ready for that, okay? Yes, some people will be like, go outside. However, if you're running outside during an earthquake and stuff falls down off the ceiling and hits you in the head, that'll probably be a problem. So that's why the best thing to do is actually to get underneath your desk immediately, grab onto a hold of that, and then just hold on until the earthquake is done, and then your teacher will let you know, okay, let's go outside, or whatever the case is. Anyway, that's what you need to do if there is an earthquake, okay? Also, if we have an earthquake drill, that is also what you should do. Thank you. All right, back to this. So this is the CER, right, on page 131 and 132. The rough draft. Again, the rough draft, this written part right here. I will talk more about it on Friday. However, the rough draft is due, right, on Friday. So if you finish this Math Connections, which is what we're going to talk about primarily in this lesson, if you finish this today, right, or you finish this already, then you can move on to completing the rough draft CER. You only have to have the written part done and submitted by Friday, okay? So you got time. All right, y'all, let's move on to this assignment here. So I'm going to go ahead and pull up the writing version of this. Well, at least I'm going to try to. Let's see. Here we go. Boom. Okay. And actually, let me move this keyboard out of the way because it is not helpful. Okay. So, let's go ahead and move right on over here. Let me get my little pen out here. All right, cool. We're ready to rock and roll. So, pause the screen, read everything here. Again, pause the screen and then read everything, and then we'll be able to keep going. Fam, did you pause the screen? Did you read everything? Come on. Come on, man. Stop trying to shortcut the system. Y'all can do this. Y'all did it. And for the people who did, thank you. All right. So kinetic energy is the energy of what? It's the energy of motion. The following two experiments were designed to explore whether speed or mass plays a bigger role in determining the amount of kinetic energy. Experiment 1 was designed to test how the effects of speed affects kinetic energy. The kinetic energy is calculated by using mass of 12 1,200 kilograms, mass of an average car traveling at various speeds, right? So this is the equation. So kinetic energy is equal to half times the mass times the velocity squared. You guys got everything broken down? This is the same formula we've been using. So what you can do, so now it's time to actually do the calculations. And make sure, two things I need you to do. Write your name. So I'm gonna go ahead and put my name right there. Boom. Mr. Farr. Okay, so Mr. Farr. And then at the very top, I want you to write show your work. Okay, I'm gonna tell you right now, if you do not show your work, that is half the credit. So you got to show your work. It is the practice, and it will help you with your learning. Trust me. So since kinetic energy, right, is equal to, right, half, which is 0.5, times the mass, which the mass is right here. Boom, 1,200. So I'm going to go ahead and put that in there. 1,200 times the speed or velocity squared, right? So that's what you're seeing right here. Boom. Okay. Then we're going to go ahead and go to 2.78, right, squared. So let's go ahead and push this over here. Now, couple of things for the people. I want you to use the Desmos calculator. So let's talk about the Desmos calculator. So I got this thing pulled up right here. Oh, let me zoom in just a little bit. Boom. So we got this all done. Okay. So in order to find the Desmos calculator, oh my gosh, I don't know why I zoomed out again. In order to find the Desmos calculator, all you have to do, right, is just Google it, right? And you're like, what? You could do that? Yeah, I'm just going to go like this. Desmos calculator, right? And I want the scientific calculator. So I'm going to go scientific, and then I already see it, scientific calculator. Boom. I'm going to click right there. I'm going to click here. And then what I want you to do is bookmark this thing. So this is the calculator that you're going to want to use. So I'm going to go ahead and make this smaller so that we can share the screen between these two. Boom. Okay. And then let's just go and zoom back in. Right? And then now let's go ahead and put all of this into the Desmos calculator. Okay? Boom. Oh my gosh. No. Okay, cool. All right. Do I need to make this a little bit smaller so I can share the screen? I guess I do. Boop. Okay, there we go. Now I got everything on there. Okay, so then I'm going to go 0.5 times 1,200. So I'll put that in there. And you can also type this. So that might be faster if you use the typing. Times. And then I'm going to go to 2.78. Now, here's something I did want to show you guys. You can just use the square function, and that will square it. I'm going to delete that, okay? But if you press this AB right here, if you press this AB, then it will actually allow you to put in any exponent you want. So if you need like cubed or you need it to the 26, you could also put negative 45. So again, you could use any exponent you want. So that function allows you to use any exponent. In this case, we just need the squared. And then it comes out to be 4,637, and we're going to round to one decimal place. So that would be 4,637.0 because, this 4, 5 or more, up the score, 4 or less, let that joker rest. Okay, cool. So let's go over here and go ahead and just zoom in just a little bit here. Oops. Boom. And then I'm going to go ahead and put the answer in there. So 4,637.0 joules. Okay, cool. That's really how you do this entire thing. So get the math done, and then here we go. If we look here, we already have some graphing, and if you look on here, right, it says draw a line graph that represents the relationship between speed and kinetic energy in experiment 1. This is experiment 1. So if we look right there, this is experiment number 1. Okay, boom. This is experiment number 1. So it is the data from this one. So make sure that you read and you're like, oh, this is experiment number 1. So we got to do that. Okay, cool. So let's go and switch back to this. And then it has these really big numbers here. and then it has much smaller numbers there. So it's saying we need to draw between, let's see, that represents what? The graph that represents, draw a line that represents, speed and kinetic energy. Now, we haven't done all of them yet, but if you look at the speeds look much smaller because the speed is only between 3 and 19. So which one of these things which graph part you think is going to be on the X, or you think it's going to be on the Y? And hopefully you're saying like, oh, well, the first kinetic energy is already, if you look over here, it's already into the thousands, so that must be this one. So this over here must be the speed, so we'll put that down there, speed. And then this over here must be kinetic energy. I have no idea if I can write, let's see if it'll let me write sideways. Oh, it will. This is crazy work. I'm going to try. Oh, that came out too bad. That came out terrible. So we're going to erase all that. And we're just going to write KE right here. This is kinetic energy. Now, if we go to graph, the very first point that we have, okay, the very first point that we have is going to be when speed is 2.7, then, right, because speed is our X in this case. So speed is X. And then kinetic energy is Y. So when speed is 2.78, then our kinetic energy is 4,637. So let's just look right here. So when speed is like I don't want to put that point on. When speed is 2.78, so this is 3, so it's probably like right in here. And then between here to here is 20,000, so about a fourth of that is what I'm looking at. Then it should be somewhere like right in there. And that's how we graph our first data point. Does that make sense? So as you're going through and you're calculating all of these, then you should go ahead and make sure that you, after you're calculating these, that you go ahead and graph them. So we'll do the very next one and we'll graph it. So enter, right? And then, so again, 0.5, and then it is going to be times, it's 1200, okay? And then times, and then it's going to be 5.55 squared, and then boom, it's 18,000, right? So I need to show all my work here, so I'm going to go ahead and do that. So KE is equal to 0.5 times 1200 times the velocity squared, which is the 5.55 squared, and then that answer is going to be 18,480 1.5 joules. Bam. So now my X is going to be 5.5, and then 18,400 is going to be my Y. So let's go on over here and see. Okay, so if I go, this is 5.5, and then 18,000 is not quite at 20. It's a little bit below that. So it should be somewhere like right in there. That's my second point. And that's how you would graph. Now, hold on, let's go ahead and zoom this joker in and go over here. And then if you look at your second page, then you can go ahead and go on to experiment number 2 and then go ahead and draw that. Oh, you know what I just realized? I put experiment number 1 on this whole page. Let's leave that, and then let's look at experiment number 2 because I have that on here too. Sorry, y'all. My bad. I just realized I did that. I messed that up. Okay. So, but I do have experiment number 2 on here. So, let's go here, slide. Adios, people. All right. Oh, you know what I just realized is I don't have experiment number 2 on here at all. So, I'm going to scan that. I'll get that on there. But experiment number 2 is done very similarly. And again, you're making a line graph, which means you're just going to connect them. So, we'll show the finished graphing tomorrow, but again, you just got to make sure to get all of your things calculated for experiment number 1. And sorry I don't have that on here, but for experiment number 1, and then you need to go to experiment and calculate everything for experiment number 2, okay? And then you're going to go ahead and make your graphs and make sure to read, because right here it says experiment number 1 for the graphing. And then right here, it says this is where you should be graphing experiment number 2. Okay, so handle your business, make sure to get those things done. And that is everything for today. Tomorrow we will take a look a little bit more at the graphing, and then yeah, you'll have this to be able to be turned in on Friday. And last thing is this is, remember, tomorrow we will be having an in-class presentation from the high school. So all you have to do is just show up, and then we'll be having an in-class presentation. Remember, this is due on Friday. We also have your journal check, which if you have everything good for that, you're good to go. And then the last thing that we have is the, what am I saying? The last thing we have is the, the rough draft. And again, you will have time on Friday, the rough draft for the CER. And again, you will have time on Friday to work on all of those things. Last thing I want to mention about this calculator. Some people do not want to use this. However, this is the calculator that's going to be on the state test. I'm keeping it real. It's going to be just like this one. So the more you become accustomed to using this calculator, then the easier all of that will be. Okay, so I just want to put that out there. So for this assignment, I exclusively want you to use this. And for the rest of the time that we have going, I want you to use this calculator. All right, y'all. Peace.